the breathing. Still, maybe the person wasn't impaired. And this can depend on a lot of things. How old the person is, how much they weigh, what they ate. Men and women can absorb alcohol in different ways and have it affect them differently. If there are other drugs in the system, even let's say blood alcohol content of 0.03 might have some interaction with the drugs and make them even more impaired. So it depends on a lot of things. So the breath test only tests for alcohol. Doesn't test for other things. So we know how much alcohol might be in the breath, but maybe the person's completely sober. So what is done are what they call field sobriety tests. These test how the brain was affected. They are reliable, although again lawyers will contest them. They are generally reliable psychophysical tests. You see how their physical actions are, and we can see how what their brain is functional, or how functional the brain is. They are not used by themselves, because again they can be argued with, but together with a breath test you can say, okay, we know this guy was drunk as a skunk based on his physical reactions and based on the breath test. So here are some examples of what's done. We're not going to go through everything. There's a professional goes through a lot of these tests. There's the walk and turn. So you make them walk 9 steps, heel to toe in a straight line, then turn around and come back. It's like an old story that a guy's drunk if he can't walk in a straight line. Well, this is similar. He's not going to be able to balance or be able to coordinate himself well by walking 9 steps from heel to toe in a straight line, turning around and coming back. Another thing they do is they ask a person to stand for 30 seconds and they have to count. So again, if the person's totally blitzed, he won't be able to count and stand on one leg at the same time for 30 seconds anyway. And then we have what's considered, again, rule of thumb, considered the most reliable test of impairment. That's the horizontal gaze nystagmus, if I'm pronouncing it correctly. So let's talk about that. That's nystagmus is when the eyeball jerks around. Now, your eyeballs are not jerking around unless you have a lot to look at. But anyway, your eyeball does not normally jerk around. But a person who's impaired will sometimes have that happen. A person, you can gaze to the side and without turning his head. I mean, you can move your eyeballs to the left and to the right. That should not be a problem. But if you're impaired, the brain is impaired by alcohol or drugs, then when he moves his eyeball too much to the left or to the right, it'll start getting uncontrollable. It'll jerk up and down. The person will not be able to keep a level gaze. This is the horizontal gaze nystagmus, where he looks horizontally, but the eyeball is going to start jerking up and down. So the more impaired the person is, the less he'll be able to look to the side. And if the eye, before it goes, let's say, halfway to the left or to the right, at 45 degrees, before it can get to 45 degrees, it starts jerking up and down, then the blood alcohol content is understood to be at least 0.1. So that's how, even without a breath test, you can pretty much know whether the person is too drunk to drive. So here are some pictures of when it's done. I would not advise everybody to start looking online for pictures of these things. People who are drunk can be, when they're called out by police to see if they're really drunk, they don't always drive clothed. So be warned if you want to look at all pictures of these things. Some of them make people look pretty silly. Anyway, just be warned. Don't look at these pictures without keeping that in mind. Anyway, here's an example of the policeman forcing them to walk in a straight line, 9 steps, heel to toe. Here is an otherwise respectable-looking fellow was suspected of being drunk, unless they're just actors. I don't know. Anyway, so he's doing the one-leg stand. Here is the horizontal gaze nystagmus. We have this guy who looks like he's like a state trooper, but I have no idea what he is. He looks like he's an official police person. Anyway, this guy he suspects, he pulled him over, I guess, at night. So he tells the guy, look straight, put your face me, but follow my finger. He's using his flashlight to look at his eyes. See, let's take a look at your pupils. Let's take a look at your eyeballs. Follow my finger. So he was following with his eyes, with his face straight. He was following his finger, and if his eyeball was jerking up and down, this guy's going to know it. That's why this guy's testing for horizontal gaze nystagmus. He's looking at him, telling him to face me, but try to follow my finger with your eyes. And he's looking carefully at his eyeballs to see if it's jerking, if he can see any nystagmus. So we don't only test for the air, for the breathing, even though it's a very simple way. Blood is considered a little bit more better because, remember, the alcohol gets to the lungs before it gets to the brain. So people do take blood tests. Alcohol, it's volatile. It does evaporate more than blood does. So since it's volatile, we have no problem with gas chromatography. That's when we evaporate something and we send it through a column, and the way it sticks to the column, we can tell what it is and how much of it is. We've dealt with gas chromatography before. One of the main problems with gas chromatography is that if it doesn't evaporate that well, it doesn't work. Gas chromatography doesn't work. You got to evaporate it. But you have no problem with alcohol. Alcohol does evaporate readily, as I'm sure we well know. So we use gas chromatography on the blood, and usually we use an internal standard where we put in, let's say, a standard of exactly 0.1, a BAC of 0.1 grams per milliliter percent. But anyway, let's say we put an internal standard that is exactly 0.1, a BAC of 0.1. Then we compare it to the sample here, and we see, is the peak that's given by the gas chromatography, is that the same size as the 0.1, the known 0.1? If it's the same size, then we know it's 0.1. Let's say it's half the size, then we know it's 0.5, and the guy's okay. If it's twice the size, then the guy's 0.2, so we know he's way over the legal limit. Anyway, so that's what's often done. We have gas chromatography of the blood. We compare it to an internal standard where the BAC is known, and we see how the gas chromatography signal compares to the known one, and we can figure out how much alcohol was in the blood. And briefly, we're not going to deal with this much. In hospitals, this is not done in the field, not done by forensics usually. In hospitals, they reacted with NAD. That's an enzyme. It will react with alcohol, and you can test it even without gas chromatography. But it's generally not done in forensic laboratories. In hospitals, it's done, but not in forensic laboratories usually. Usually, they do the gas chromatography. Okay, so suppose you get the blood for whatever in whatever case. The truth is, if you want to take blood from somebody, if you can't do the breath test for whatever reason, and you want to take blood, an ordinary person cannot take blood. You must have a trained medical personnel take blood. Ordinary people cannot take blood. That's not allowed. That's not legal. You never know what the people might do. Medically trained people know to sterilize and know how to do it. They know how to do it more in a way that's more efficient. That's maybe less painful. You need medically trained people. When you want to sterilize, let's say, the place where the needle is going to go in to suck the blood out, you can't use ordinary alcoholic swabs, which is what everyone else does, because we don't want that alcohol to confuse the tests. So what we do is we use, let's say, mercurochrome, some other sterilization agent, so that the needle is clean. When we get the blood, it's got to be stored in an airtight container with a special anticoagulant and a preservative to stop bacteria from eating the alcohol or eating the blood and making their own alcohol, or who knows what they do. We don't want bacteria to grow there. And put it in the refrigerator or freeze it sometimes, whatever it takes. Try to keep it from evaporating or reacting or changing, because pretty much anything that happens naturally to blood over time will make the blood alcohol content go down. So if you